at the opposite of the right
Yeah,
end.
you didn't read.
Yep,
Yeah, you're right.
I know. So number 10. I did point out to you guys, this is one of the ways the Regents will mess with you. My guess is this question went along with, it was probably, they gave you this diagram and then asked like 4 or 5 questions about it. So they started off by telling you that there was an epicenter at Northridge, California. But then if you read the actual question, it had nothing to do with Northridge. Their question was about, wow, I'm struggling here. Their question was about Oakland. You had to do the latitude and longitude of Oakland. I let you use a ruler, so if you had wanted to draw these in, here's the 37 line. God, I keep running out of ink on my pen. You could just leave it right up there. Thank you. All right. So there's the 37 line, the 38 lines on the top. So is Oakland 37 or 38? Right, 37 degrees is the whole number, but we don't care about just the whole number. How many minutes was that? One thing you might have wanted to do is note that was the halfway mark.
I thought it was like 30.
I said 30.
I accepted 30 minutes. By the way, north, south, east, or west? North, you had to include the correct label. So I would have taken, like you guys were saying, like 31 or 32 minutes as well. But it definitely wasn't 38 and it definitely wasn't 37 even. Now the longitude is where people started screwing up. So here, that's definitely a screw up. There's 121, here's 123. Hey guys, what's halfway between 121 and 123? Oh, 122, not 121 and 30 minutes. The halfway mark, this is the 122 mark. And so I do believe I accepted 122 degrees west, or did I mark that wrong on somebody's paper? And is that what you got? Why you got it wrong? I'll fix that. So Chloe needs. Okay. That's, I think I ended up, oh, but you got.
I got that.
Okay, so not for you. But you got 37 wrong, so. You too, and you got the 36 part up, so. Okay, so I may have circled the 122 for a bunch of people, but you also lost points other places, but. It is officially not right on the 122. It's just a little bit past it. So officially I would have gone with more something, sorry, struggling. Like 5 minutes or 10 minutes, 15. I accepted it, right? Yeah, I think I went up to 15. You did have to label it west. Another thing is, guys, I know sometimes a messy N can sometimes look like a messy W and vice versa. Please don't do that. It has to be neat, clear, because I did mark somebody's wrong and I did look at it. And I'm like, I bet that's really an N, but it really looked like a W. Be very careful that your letters in this case, like normally, I can decipher a lot, but if it clearly needs to be an N or a W, make sure your letters don't look like the other one. Any more questions that you absolutely want me to go over, you don't get? Yeah. Uh-huh.
What about number 2?
Number 2.
No,
Yes. Did you put A? Yes.
I knew Watertown was closer,
Yep.
but Plattsburgh was in 44.
Yeah.
So.
Yep. I knew what you're doing. And I thought about it, but this was an actual Regents question. So I didn't make this, and this is how mean they are. I mean, I have told you guys, I know I say jerk faces, but I want you to insert like meaner words when I say jerk faces. I just can't say them to you, but I want you thinking, anytime you hear me say jerk face, I'm thinking a way meaner name. Okay. They're jerks. And the question asked, Who would see Polaris at a 44 degrees in the sky? And you should have then remembered that 44 degrees in the sky means that this person is standing at 44 degrees north. And like Trey was saying, Plattsburgh's latitude is in between 44 and 45. Plattsburgh is around 44 degrees, 45 minutes north. So like Trey's saying, it's in the 44s. But if we look at Watertown, they're like almost exactly on the 44 line. Yes, they are like 43 degrees, maybe 59 minutes, but they're practically 44. So that is a jerk face question. Not gonna argue with you there, but Watertown is way closer to 44 than Plattsburgh, even though Plattsburgh is high in the 44s. Everybody that got it wrong made me think maybe I should give them credit. But knowing that this is a question the Regents has truly asked with those exact answers, I couldn't go back. They're that mean, and I need you to get used to being mean on something that means barely anything than to bomb the Regents because you're not used to them being mean.
Like, so this is like an actual question.
All of these, I pull them right off of old Regents questions, not just practice questions. Literally, this was on, I could look it up if you need me to. I could tell you what year and what number it was on a Regents if you really cared that much. Okay, I will have to do it later, but it is truly a Regents question that showed up one year. Olivia, you had another one? Yeah. Number 6. I asked which one you picked. Which one? You picked C. Wait, that is the right answer. I marked it wrong.
No, I have D.
It is D. That's right. It's D.
You marked me wrong.
On D? On 6?
Oh, sorry.
Sorry to get your hopes up.
I got it.
Both of you, I'm just sorry to get your hopes up. So, Olivia, you reversed it. Latitude, flatitude. These are the south number. Like, so these would be the norths. These are the souths. So it's 5 degrees south, not 5 degrees west. Okay. So we got to always do the latitude, flatitude ones first. And then longitude, where I thought you were going to say you messed up. This is where most people messed up. Prime meridian's down the dead smack center in this one. Unlike the one in our reference table. Remember, in our reference table, the prime meridian's off to the side. Don't get hung up on right or left side being, in this case, the right is east. I'm sorry, the left is east and the right is west. Just get hung up on if you go to the right of the prime meridian, that's east, and to the left of the prime meridian is west until you get to 180. So this would have been at the 30 degrees west side. So you did reverse your west and east. Right numbers, wrong labels. What other ones? 7. Hydrosphere at the beginning of this chapter. Well, people make mistakes. At the beginning of the chapter, I did ask you to label these as rocks, water, and air. Now, while you didn't technically have to label them, that is information you need to remember. The hydrosphere is water, not hydrogen, it's water. So we did need the one that it is the liquid outer layer of Earth. It's the water layer. I absolutely want to just talk about 12 as long as we're on lithosphere, hydrosphere, atmosphere. If you picked A, you fell for their trick again. One thing I do when going over any of these, I can even show it to you on my answer key. I circled, they wanted it in increasing order. Increasing order means it's going to get bigger. So we want the least dense to the most dense. Air is the least dense. Rocks are the most dense. Water is in between. That's answer C. Again, if you picked A, you went most to least. Yeah. Mhm. That's one of those, I call them silly mistakes. Not, you messed up the reading, not the earth science in that case. So I'm actually happier if you picked A than if you picked B or D and got it wrong, because at least you know your earth science, but you fell for their tricks because they're jerk faces. Any more that you just know you want to go over. All right, just in case you do not have all of the right answers and you want to study from this, go back to the page 1. Just to go through and double check, number 1 is C. Number 2, B. 3, B. 4, C. 5, B. 6, D. 7, B. Ooh, 8's actually another one. Oh no, 8 I don't need to go over. 8 is D, but I did want to talk about 9. 9, the correct answer is D. Again, it's really important. They wanted longitude. I personally, here's my answer key, circled the word longitude when answering this. Longitude, remember, they're the up and down lines. They meet at the poles. They're not parallel. What I did is I went through and I crossed off anything that was parallel to itself. Because those show no, they don't. Those show latitude. Latitude are the parallel ones. So that left the only possible answer could be D. And I did verify the longitude. They go up and down and they meet at the poles. Here's what that would look like from the North or South Pole. They touch in that like bicycle spoke pattern. We talked about 10 already, 37 degrees, 30 minutes north-ish, and 122 degrees, 5 minutes west. 11, the answer is D, and 12, C. First, did I screw anybody's up? All right, sorry I didn't screw any of yours up. Are you sure you don't want to talk about any more? Okay. If I gave you another quiz, do you already feel like you might do a little better? Some people still say no. Okay. So we'll do some more practice and take another quiz on that coming up. But in the meantime, grab your packet. Open it up to page 19 where we left off yesterday. And if I remember correctly, we already had the vocab, all of these vocab words, right?
Yeah.
Awesome. So we're getting into talking about contour lines and contour maps. So we ended off here at contour maps. And I mentioned how when people contour their face, it's to like emphasize the shape or to bring out the shape of your existing face. Contour maps are going to show you the shape of the land, whether it's a flat land or a hilly place, or if the hills are super steep or if it's a nice gentle walk up that hill. That's what a contour map's going to do. Just like contouring your face shows the shape of your face, contour maps are going to show you the shape of the land. For example, here's some mountains. Each one of those lines is a contour line. Okay, so what it really would be is if somebody went to this mountain and had like some brown spray paint and they spray painted everywhere that was 0 feet above sea level. By the way, why is 0 feet right where it is?
Because that's where 0 is.
Why?
That's where the sea level.
That's where the sea is. So if you're in an ocean, if you are at the ocean where the land meets the water is clearly 0 feet above the sea. So you're literally right there. That's why the 0 is on the edge of these maps. So somebody went with brown spray paint and sprayed that 0 feet line. Then they decided to do the same thing. They went up and they hovered around the 500 mark. And then the 1,000, and then the 1,500, and then the 2,000. So in this case, they went every 500 feet. Why didn't they go every foot?
Cause there'd be too many lines.
You basically had just, it'd be so messy you couldn't like look at it. You would have basically colored it in almost if they went every line. So they never ever go every line. And we took those notes yesterday. This bullet right here, the contour interval is the difference in elevation between two contour lines. Or in other words, what they count by. So on this mountain, they were counting by 500s. Drawing a line every 500 feet till they got to where there was no more to draw. Now, why didn't they draw a 4,000 line on here?
Because that's as far as we go.
Yeah, this mountain is only 3,998 feet tall. There is no 400 mark because there is no 4,000 mark on this mountain. Yeah,
What if the sea level went down?
yes, then they're gonna have to adjust it. Good point. But remember, a map is just a snapshot at that particular time. So that's why on this map, we don't have to worry about the sea level changing. So the contour lines always, let me rephrase this. The contour lines don't always show exactly how tall the mountain is, because if the mountain stops before the next line would show up, you don't know exactly how high it can get to the top. We'll talk about that as we go on with these. So this is what the mountain would look like from the side if you were to draw the contour lines, which you guys can kind of see. I have a fake mountain here. So you can see the shape of the land. But then let's look at what would happen when you turn it this way and you look at it from the top. So let me show you what it would look like from the top. So these are those same lines if you hovered above the mountain and looked down at them. So you can still see where the mountain is, and then you can see these lines on the inside. What are some things you notice about these lines?
Or, that word? Perpendicular. to
I
each other.
think you mean parallel to each other?
Parallel.
What, you mean not touching?
Yeah, but they're like following close over.
That's exactly what I wanted you to notice. We call it having a parallel trend, because they're not perfectly parallel, but they're I actually call it parallel-ish. So they're almost parallel. So notice, see how there's like, this is the best example up here. So up here at the top, see how there's this big divot in? See how the next line still has that divot and another divot and another divot? Where one line goes, the rest of the lines go like that too. Not perfectly parallel, but almost parallel-ish. They also never touch. What would happen if these two lines touch? What would it mean if 0 and 500 were touching each other?
That'd be like big cut in something. It'd be the same.
It would be, what would be the same?
The level.
The level, the elevation, yeah. If there was a 0 touching a 500, that means at that very moment, the elevation was both 0 and 500 feet. Is that a thing? It can't be at the very exact spot, at least. So they can never touch. They follow each other's path. And I think you guys got the gist of what you're supposed to see here. What is happening to the clock?
Turning.
It is turning.
It's 5:15, it's at a pixel.
Oh, you know what it means? It means it's almost tomorrow and I get my puppy tomorrow. So very excited. Yeah, I'm getting my baby tomorrow. I'm so excited. A new Doberman. So a baby Doberman. I'm so excited. His name's gonna be Mac. I'll show you guys lots of pictures on Monday.
Yeah.
Or is it already past? We don't know when it started moving around like that. Moving on. You guys are gonna get real familiar and real comfortable looking at these maps. You are going to have to draw these maps. So we're going to have to basically do what this person did and walk around the island and paint the lines on the island. So you got to draw them. Then you got to be able to read them. So you got to be able to tell me like what's the highest number, what's the lowest number. Then we got to start talking about the steepness of the hills. Okay, we're going to get real comfortable with them. Okay, thank you. Here are the rules for drawing them, which is where we're going to start. So if you could go to the bottom half of page 19, the rules for drawing iso lines. There are 5, and I don't know if these are rules or steps. They're kind of a combination of the both. First thing first, so you already have ISO lines written. ISO lines connect points of equal value. Bottom half of page 19 says ISO lines. Your first one is going to be ISO lines connect points of equal value. Maybe they're making it so that the bell actually rings when it's supposed to and not a minute later. Maybe they're trying to.
Per chance.
This reminds me of Connect the Dots. Like, you know, when you go to Olive Garden, you got the children's menu in front of you and you get to do Connect the Dots.
Yeah.
And you make some sort of like cat, like sailing on a noodle at Olive Garden, something. It's always something weird at Olive Garden. This is like that. The only difference is, unlike Olive Garden, where you start at number 1 and go to 2 and 3 and 4 and 5, here we're connecting all the equal numbers. I call it Connect the Dots for slightly older kids. So you're connecting the dots, but it's a little weird because you're older. So you're connecting all the equal numbers. So if these were all dots up there, that might be one thing you do, is you connect all the 10s.
Are they allowed to cross to the other line? Can we?
What?
Go through the,
Can't go through the other line, right? So
how the heck?
well, just wait, we're not there yet, dude. So you're connecting all of the equal numbers. Rule number 2. ISO lines are gentle curving lines, no sharp corners.
Okay.
Just like, again, if you were doing a cat, connect the dots. If you used all sharp angular lines from when you're connecting, your cat's gonna look funny. It's gonna be a little bit like pointy instead of a curvy, cute, fluffy cat.
Spiky cat.
Yeah, instead you get a spiky cat, more like a robot cat, I guess. Yeah, I mean, that it's gonna look like a Tesla truck instead of an actual truck, right? I mean, not that a Tesla truck isn't a real truck. I don't know.
I don't think it's flashing by.
Anyway, I probably won't mark you off for this, but if you were to do this in real life, you do need those curvy lines instead of sharp angular corners.
Right.
Logan, dude, take a break, man. Number 3. There are always going to be these closed loops. That was actually one of the other things I wanted you to notice on the one that I had before, but I forgot. So they're always closed loops. But your map that you're working on might not show the entire loop, might cut it off slightly.
Okay.
Logan. Like it's better when you're quiet.
That's important.
Had a feeling that was going to be the case. So what this means is, I promise you, somewhere in the world, your lines will make a loop. And I call it a loop. You can also think circle, except for it's not a perfect circle. They will always be closed somewhere in the world. But your map might not show it. Your map might cut these off. So one thing that you need to pay attention to is that the lines will never just stop in the middle of a map. They will either close up into a circle-ish shape, or the lines go to the edge of the map. That is a rule. So they either go to the edge of the paper, or they make that loop shape. Those are the only ways. We're not talking about the one on the bottom yet, Trey. Number 4, here's where, Carson, you asked us a minute ago. ISO lines will never, ever cross. So if you're attempting to do the one on the bottom of the paper already, and because we're not doing it, that's why. The one on the bottom was just for an example, and maybe it doesn't work. It's hard to say. Yeah, I don't know what was, I have a feeling at some point when on the Word document, the numbers got moved around. So this one, and we already talked about this, if they did cross, then you automatically know it's wrong because it can't be the two numbers at once. It's just not a thing. Yeah, if it was a temperature map, it might be a different number later, but at that very moment when the map was made, it was only one temperature.
We're back on time.
I think it's the exact, oh, nope, it's 11:06 now. Now we're 2 minutes behind. And finally, this is what Logan noticed at the beginning. ISO lines are usually parallel or at least have a parallel trend.
What does perpendicular mean?
Makes 90-degree angles. Parallel means they never touch. Perpendicular means they make perfect 90-degree angles. Look at me teaching you math. Yeah, I know, I can't help you with that. So I'm very lucky Grace has the math stuff down pat, so she can help Mallory with it in 2 years, because I can't do it. All right, moving on. You guys really want to practice this stuff. So let's give it a whirl and practice a little bit. So first off, what is this? So for those of you who wanted to try this one, I don't know what happened, but it's not working this year. It has worked in the past, so I'm guessing it either formatted different. Yeah, I think what happened is this is the same packet I used last year and they upgraded Microsoft this year. So I have a feeling the formatting changed when I hit print and I didn't even think of it. So we're going to switch to page 20. And this doesn't look what? This doesn't look better? It is better, I promise. So what we got going on here is this is representing a whole bunch of elevations out in some imaginary field. And we need to see, well, what does the shape of the land actually look like? Because having all these numbers isn't super helpful. But once we start doing the connect the dots for slightly older kids, you're going to find out it's going to look like one of those, like a map that shows elevation like I showed a minute ago. We have to follow the steps. And to start with, we should read the directions, which for some reason I put them on the bottom of the page. And again, I don't know why, but I did. It says, assume the data was measured at the center of each number. So what I'm telling you is pretend there's a dot in the middle of each number. Highlight the data points with the same value in pencil, connect the dots with a smooth curve, and they tell you that the contour interval is 10 meters. This is the part we need to focus in on. What does it mean, contour interval of 10 meters?
Make a line every 10.
Make a line every 10 meters. We don't want to connect every single number because it's going to be too messy. Hang on, Logan, let me walk through it. So without even looking at the map, if we're going up by tens, what number do we start with? You would think 10, but what comes before 10? 0, then 10, then 20, keep going, 40, 50, 60, 70, and 80. So looking at the map, is there any 0?
No.
There's no 0. Is there any 10s? 20s? 30s? 40s. Now, when I say 40, I only care about 40, not that 41, not the 45. Is there any 4040s? This map does not start until the 50. I had asked you to bring a highlighter. If you have one, can you grab it? If not, there's some up there in front. Highlight the 40s. The 50s, the 5050s. There are 9, I believe, we counted last period. I know there was at least 8. 1, 2, 3, 4, 5, 6, 7. Now I can only find 7 right.
8.
Where's the one I'm missing? Oh,
I'm not, no.
wait, okay, so where am, which one?
There's another one, the middle column. One right up.
So there's 9. 1, 2, 3, 4, 5, 6, 7 up top and 2 down below. So you, does that mean there's only 9 spots where a 50 exists? There are other places that 50s will belong. And so what we want to do is start connecting these up. But we can only put a line where 50 truly lives. So here's 50 and there's a 50. Would it be safe to connect them up like this? What I mean is there a 50? Does 50 belong in between 48 and 55? 48, 49, 50, 51, 52, 53, 54, 55. So yeah, they do exist there. Going up through here, you're just going to cut through there. 49, 50, 47, 48, 49, 50. One thing I want to notice is, what do you notice about all the numbers to the left of your line you just drew? They're all smaller than 50. What do you notice to the ones to the right? They're all bigger, at least for a little while. We'll have to draw some more lines, but we're out of time. So as long as you got to there, we're good for today. And we'll pick this up with reviewing what we just did now. We'll continue to do that on Monday. No homework. Please enjoy your weekend.